Hello there, folks. We're here with section 2.5, and this section is all about literal equations and formulas. Now, you might be asking yourself, what the heck are literal formulas, or literal equations? And you may know what formulas are. But either way, we're going to be working with both of those today. They're very similar. And our learning target for today is to rearrange formulas to highlight a specific variable. So this is section 2.5 here. And the background picture, I have LeBron James, on there, along with wearing a USA jersey in the Olympics, mostly because when I'm making this video, he just won the NBA Finals, and the Olympics are coming up. So pretty sweet stuff. Anyway, let's start it off. What is a literal equation? Literal equation is an equation that just involves two or more variables. So we've been working with all these one variable equations. These are going to have two or more variables, and we're just going to solve for one of them. Kind of like a formula. A formula is a literal equation. Technical definition here is an equation that states a relationship among quantities. In other words, it's a literal equation. But we're talking about like specific measurements for the variables. All right? So, how are we going to do this? Solving equations with more than one variable. In other words, solving literal equations. Literally. Oh, I guess I covered up Kobe there. Whoops. All right, we're going to make it three easy steps, and they're very similar steps that we've done before. Start by locating the variable you are supposed to solve for. All right. Um, Undo any addition or subtraction that's happened to the variable, and then undo any multiplication or division. Now, if there's a case where you need to do some distributing or combining like terms first, do those first, just like with multi-step equations. But I think for the most part, I'm going to keep it to those steps. It's really the same steps as multi-step equations. These things just look super weird and annoying because there's more than one variable and they're not numbers. All right, necessarily. Um, Using formulas, I have a list of formulas here for you, and it's up to you if you want to have these written down. We will use some of these from time to time. Um, you should know, hopefully, the perimeter, the two lengths plus the two widths. Circumference of a circle is 2 pi r. I might underline some of the ones you should know. Perimeter, circumference of a circle, area of a rectangle, area of a triangle, and area of a circle. These are all ones you should know: length times width, 1/2 base times height, and then pi r squared. The last two, we won't really be using those a whole lot, and if we will, I'll give them to you. Okay? But those are just some general formulas that will be used in this year or this section. So, a couple examples I'd like to go through, and I have the work underneath here, but I actually just want to go through the work next to it. So we have 5b plus 12c equals 9. So now you see where there's more than one variable, and it's not just all numbers other than the one variable. So we want to solve for b. That means we want to get the b all by itself. All right, so let's first, there's no distributing or any combining of like terms that can happen. So let's look for addition or subtraction. There is this plus 12c, which has nothing to do with the b, so we're going to get rid of that first. And this is where it might look, after we do that is where it might look kind of weird, but we're going to subtract 12c from here to get rid of that right there. But then we have to do this to the right side as well. Minus 12c. So the left side is simply going to look like, it's going to be 5b. On the right side, technically it's 9 minus 12c, and we're going to change that to plus a negative 12c. All right. So now we just have 5b on that side. We're still trying to solve for this b, so we have to look for any multiplication or division. And that right here, this is multiplication, 5b. Again, this is a 5. That was a bad 5. But we got to divide it to get rid of that multiplication. That makes sense. On the left side, on the right side, we're going to divide this whole side by 5. All right, b is equal to. Now the way we would normally do this, and we'll get into this more later, is we divide both the 9 by 5 and the negative 12c by 5. But since neither of them can divide evenly into 5, we're just going to leave it either like this, or we can do 9 over 5 plus negative 12c over 5. All right, and that's what b is equal to. Yes, we have all that in there. We don't just have it equal to a number. Since there's more than one variable, that's how it works. All right. And I think that's what I end up with here. Again, you can leave it like this as well. So we'll say or, and do it like this. All right. Try this next one on your own, why don't you? We have 3x minus 4y equals 7. 3x minus 4y equals 7. We're trying to solve for y. All right, first thing, make sure you change this to plus and negative so we don't get confused here. But we're trying to solve for that y, so let's get rid of the thing that's added to it. This is 3x, so we're going to subtract 3x. So we start off with 3x plus negative 4y equals 7. And I'm just going to do this. I'm going to subtract the 3x that's added to it. So I have negative 4y is left on the left side. And 7 minus 3x, which is plus negative 3x. And then finally, any division, multiplication or division, there's multiplication here. And I'm going to divide to undo it. Divide by that number in front, which is a negative 4. And I have to do that on the right side as well. So, like I said before, you can leave it like this. Ooh. Alright, here's 3 different ways to leave it. I forgot about that. Alright. One, you can go 7 over negative 4. Plus then the negative 3x over negative 4. And those negatives cancel each other out, so they're both positives. You can write it like that. I'm going to actually make those disappear here. That is a 4. Or you could leave it like this. 7 plus negative 3x over negative 4. I'm going to cross this out because I don't agree with myself now. You are allowed to have a negative denominator if you want. It's just not necessarily proper. So if you want to get rid of the negative denominator, you can rearrange these, but you can change the signs on everything. So really what happened here was we canceled out these. These became positive. This became negative, and this became positive. It's changing the sign on everything. And then I switched it around. So really, as long as you can get to this or this, I'll be happy. You're doing your job. Let's skip down here to the formula one. The formula for the volume of a cylinder is V equals pi r squared times height, where r is the radius of the cylinder and h is the height. What is the height of a cylindrical swimming pool that has a radius? All right, we have our radius of 12. And a volume, oh, we have the volume of 1810. So we can plug in for the formula that we were given right here. 1,810 is equal to pi times 12 squared times the height. And we're trying to solve for the height. So we're just doing like we're solving for a variable. All right, this is how I would do it. I'd plug it in right away. And what you can do then, this would be 144. You can divide both sides by pi first if you'd like. To cancel out the pi, you divide that by pi, see what you get there. Then divide it by the 12 squared, which is 144. So we divide this also by 144. So h is going to be equal to, since I don't have my calculator right now, I'm just going to leave it as 1810 over 144 pi. But I would actually prefer if you took your calculator and figured out what that was equal to. Alright, let's see if I did that for you. Let's just try to recap here. So it ends up being about 4 feet. Alright. Make sure you have feet on there. So that's working with literal equations and formulas to solve for the missing piece. Now I do have one question for you to think about before you go, or as you come next time to class or talk to me next time. It says, describe the steps you would use to solve ax minus y equals w for x. We just want to solve it for x. How would you do that? Describe them in words. All right, and if you want additional resources on to help you out with these, there's two different links down at the bottom here. Well, that's it for literal equations and formulas. Literally, I'm done. We're done. I hope you learned something. I hope you're able to kind of look back and think about what you learned and how to do this literal formulas and how it's so similar to actual multi-step equations. All right, and if you have questions, bring them next time. Otherwise, use those extra resources and try to figure out this topic right here. Have a great rest of your day.